Okay, y'all. I want you to take the next 20 seconds to update your table of contents. Pause the video if you need to, because I'm not going to wait 20 seconds. Next, go to today's page. If I were here, you know I'd be setting a timer and saying you have 60 seconds to write your essential question. Well, I'm not going to give you 60 seconds, so if you need to, pause the video because I'm going to keep going. Write your EQ, 60 seconds. Okay, now that you have your title, you have your essential question, you should have your page number. Don't forget to number your page. Let's go ahead and talk about probability. We are talking about arrays today. Arrays are just a fancy way of saying, kind of like, I think of it like the multiplication table. When you were in 4th grade, you learned your multiplication facts by using an array. 1 times 1 is 1. 1 times 2 is 2. It looked like an array. I'm going to show you what arrays are today, but first, I'm going to start you off kind of simple. Write down this statement. Pause the video so that you have a moment to write down what you see. Go. Okay, now that you've written that down, let's talk about that. All the possible outcomes of rolling 2 6-sided dice. Well, if you imagine dice, imagine rolling dice, pause the video and think, what are all the possible outcomes if I roll dice? Go. Okay, what I'm asking is, what's the likelihood? What's the outcomes? What can happen if I take this dice and roll it? I take this dice and roll it. Well, here is one possible outcome. I'm asking you to give me all of them. So here's one. Lands on 6, lands on 4. Think of an organized, efficient way to get me all the possibilities. Pause the video and try it on your own. Okay, now that you've tried, let me show you how to get this organized list. The organized list should look like this. The first possible outcome would be, in an organized manner, the first dice landing on a 1 and the second dice landing on a 1. I'm going to show that first possible outcome like this. 1, 1. 1 down, I wonder how many there are to go. Well, the second logical one I would do would be landing on a 1 and then landing on a 2. That's my second possible outcome, a 1, 2. Hopefully you're seeing a pattern. Next, I would say a 1, 3. 1, 3. It could also land, the first dice lands on a 1, the second one lands on a 4. 1, 4. See if you can beat me. Finish writing all the possible outcomes. Go. I'm halfway done. I wonder if you can figure out how I knew I was halfway done. Think about how many rows I should have left. Done. I hope you beat me. I kind of took my time on that one. Okay, let's make sure you understand. What if I was in class and I asked you, what does this outcome mean? You should not tell me the answer is 3, 4. You should be able to explain, Pause the video and see if you're going to say what I'm about to say. You should say that this outcome means rolling the first dice and it lands on a 3. Rolling the second dice and it lands on a 4. If you did, pat yourself on the back. Nice job. Okay, so my next question for you is, right here in your notes, fill in this sentence stem. There are blank total possible outcomes. Option 1, you could go through and count them one by one. Or option 2, can you think of a more mathematical, efficient way to figure out that yes, in fact, there are, good, I hope you said 36 possible outcomes. How could I have gotten 36 without going 1, 2, 3, 4, 5, 6, 7, 8, 9? What could I have done? Good. Hopefully you said multiply 6 by 6. Kind of like your multiplication table. Hint, hint, hint. That leads into the arrays. Making an organized list is very, very sophisticated as mathematicians. It's also very logical. It makes sure that you list all your outcomes. However, it takes a lot of time. That was a lot of time it took for us to write that down. So instead, I'm going to show you another way that we could have gotten all these possible outcomes. This is an array. We're going to create our first array. So get ready. I'm moving to the bottom of the page. Right here below this sentence stem, let me show you how to create an array. First of all, another word for array is called an area model. And yes, you're thinking of the actual area, like area, volume, perimeter. It is considered an area model. Hopefully, you'll be able to discover on your own the connection, why we would call it an area model. To create this array, we're simply going to think about these two cubes. We're going to think about all the things that could happen. First, though, we have to use our vocab word, our events. The same way with the tree diagram, we think about how many events there are. Look at the first event, rolling the first dice. Second event, rolling the second dice. Those are the two possible events in this situation. So that's where we start our array. Event 1 goes across the top. The first event would be the first dice. Rolling the first dice is the first event. Event 2 is going to go not horizontally, but vertically, rolling the second dice. So event 2 will look like this. Dice 2. Then you list all the possible outcomes. What are all the things that could happen when you roll the first dice? Well, you know, there are 6 possible outcomes in the first event. Lots of vocabulary. I'm trying to stress the vocab. So I'm going to list those 6 possible outcomes in the first event. The first outcome, it could land on a 1. It could land on a 2, a 3, 4, 5, or a 6. I then do the same thing for my dice 2. It could land on a 1, a 2, a 3, 4, 5, or 6. I hope you're starting to see the multiplication table. Now I'm going to create the array. Here's my first event. Here are the possible outcomes. Here's my second event, and here are the possible outcomes. To create the array, I'm now going to separate each of the possible outcomes the same way you would a multiplication table. Please see if you can beat me in drawing our horizontal lines. Please see if you can beat me in drawing our vertical lines. Hopefully now you can see why I said it's very similar to a multiplication table. Here we go. I'm going to give you two numbers. I'm going to see if you can figure out how I get these two numbers. The first number, I'm going to put it right here in this corner. Believe it or not, I'm not going to put a 1. I'm going to put a 2. How would I get a 2? Okay, to make sure you understand, in this section, look very carefully. Right here, I'm not going to put 12, I'm going to put 7. How did I get 2 here and 7 here? What does this 2 mean? What does this 7 mean? Hopefully you figured out I'm not multiplying. This is not a multiplication table. This array we've created is actually that's correct, sums. I'm going to list all the sums for each of these events. So right now, I would write sums. That's what this array is displaying. So let's make sure you understand. 1 plus 1 is 2. That's where the 2 came from. 3 plus 4 is 7. That's where I got the 7. Let's finish this array. Pause the video or see if you can beat me. Then fast forward the video. See if you can find a pattern. There are lots of patterns. Done. So again, it's like a multiplication table, but arrays can represent all different types of operations. This one we've done together represents the sum. So it'd be like this. I roll this cube and it lands on a 1. I roll this cube, it lands on a 1. I would be asking what is the sum of those two outcomes? Well, I can find that right here. 1 the first cube, 1 the second cube is a sum of 2. Again, my question is, how many possible outcomes are there? Is our answer still 36? Yes, the answer is still 36. Miss Leonard, why would we do this? Why would we create an array like this? It's not very efficient. Believe it or not, it's much more efficient than some of your other options, and let me prove it to you. I could ask you for this. As a mathematician, you should know exactly what this question is asking. What is the probability of a sum of 6? Well, if I didn't give you this array, look what that would look like. I'd ask for the answer. What's the likelihood that you take 2 dice, and no, I'm not going to give you 2 dice, and you roll the 2 dice? What's the likelihood that you would get a sum of 6? Well, option 1, you could roll these dice over and over and over. Or option 2, make a really quick array. Look how fast we're about to get this answer. Probability that I get a sum of 6. Well, everything you see in pink, those are all my sums. So I want to know what's the probability that my sum is a 6. Well, let's find out. I'm literally going to go through and find all the 6s. Here's the first one. Sum of 6, a sum of 6, sum of 6, sum of 6. Look how quickly you can get that answer now that you've created an array. The likelihood that you get a sum of 6, pause the video, Try it on your own. See if you get the right answer. Okay, if you did that correct, then you said the likelihood, the probability of a sum of 6 would equal, out of 36, there are 5 probabilities, 5 possibilities of getting a sum of 6. Well, you know you're a mathematician. You can't stop there. We need our statement, fraction, decimal, percent. Do not grab a calculator. You should, as a 7th grade honors math student, be able to tell me 5 out of 36. If you need to, pause the video so that you can give me this probability. Give me this fraction as a decimal. How do you do that? I will very quickly remind you. To change this to a decimal, you're going to do what this division bar says. Divide. 5 divided by 36. Pause the video, calculate that on your own. Do not use a calculator and see if you get it correct. Please remember you have to add a decimal and a 0. Put the decimal straight up in your answer. If you do this correctly, then you should get a 1, a 3, and a whole bunch of repeating 8s. I want this rounded to the 100th. So this is not going to be 13 hundredths, but 14 hundredths. 5 or more, raise the score. Change this decimal to a percent, and you get 14%. I would say, what questions do you have? However, I'm not in the room. So here's the other one I want you to do. After you write this down, pause the video, try it on your own, then press play so you can check your answer. Example 2. What's the probability that you get a sum of, let me pick a good one for you. Let's do a sum of 9. Pause the video and then come back and check your answer. Okay, if you did that correctly, then here's what we should see. The probability of a sum of 9, well, I'm just going to go through and count the 9s. There are 1, 2, 3, 4 of them. There are no 9s anywhere else in this array. That's why this is such a great visual. There are 4 9s out of 36 total outcomes. Not okay to leave this fraction as this in this form, as you know. You must simplify it to 1/9. If you remember 1/9 as a fraction in 6th grade, we noticed there was a pattern when the denominator is a 9. 1/9 as a decimal is 11 hundredths. 2/9 is 22 hundredths. 3/9 is 33 hundredths. 4/9 is 44 hundredths. We found that pattern in 6th grade. Hopefully you remembered that. And my percent is 11%. Pause the video, take a moment to look back over what we've done so far because we have 1 down, 1 to go. I showed you the first array. We have only one other array to do. Okay, I'm out of space, so if I were you, flip the page, turn over. We're doing 2 pages today, 1 page down. Here's your second page. I would just write continued, ... It's the same EQ, same title, just covered over 2 pages. Okay, this time I'm not going to say it's dice. This time it's going to be a spinner. Probability is a lot of marbles and dice and spinners, lots of those types of situations. So draw this spinner. Four sections on the spinner. A 1, a 2, a 3, not a 4, a 6. And it is a spinner, so somewhere draw your little pretend arrow that you're going to be spinning. If you were a spinner, you'd be able to flick the arrow and it would spin, spin, spin. You get the idea. Okay, you're going to write this sentence just like before. I'll say it out loud, then I'll write it down, pause the video, write the sentence down. The spinner is spun twice, and the results of the 2 spins are multiplied to produce a product. write that statement down right below the spinner. Okay, hopefully you beat me and you wrote it down when I said to pause the video. Okay, it says now we're going to, just like before, I'm going to show you both options. Just like with the tree diagram versus a list, we're going to very quickly create an organized list of all the possible outcomes. We're going to do this pretty fast though because it's already our second one. What are all the possible things that could happen if I spin this spinner twice? Well, be logical, be efficient, think of a way to do it so that I make sure I don't miss any outcomes. Okay, you ready? First outcome, the spinner lands on a 1 on the first spin and then yes, it can land on a 1 again. It could land on a 1 the first time, 2 the second time. 1 on the first spin, 3 on the second spin. And then a 1 on the first spin, 6 on the second spin. There are no other possibilities of the spinner landing on a 1 the first time. This takes care of all those possibilities. Logically, I'd move on to the 2. The spinner can land on a 2 the first time, 1 the second time. 2 the first time, 2 the second time. 2 the first, 3 the second, and then 2 the first time, 6 the second time. Can you tell how far I am in our list? Am I a quarter of the way through? Am I halfway through? You should be able to tell I am. That's right, halfway through. I've taken care of this possibility and all of these possibilities with these being the first spin. Now I'm going to take care of 3 being the first spin. Ready? This says I land on 3 the first time, 1 the second time. 3 the first time, 2 the second time. 3 the first time, 3 the second time. 3 the first time, and 6 the second time. Last, let's finish up. I could land on 6, then 1, 6, then 2, 6, then 3, 6, then 6. You should be able to see lots of patterns just in this list alone. Lots of patterns. Okay, well that's a list. But now let me show you how an array would be so helpful. I would not ask you, hey class, what's the probability of landing on a 3 the first time and a 6 the second time? If I did, you'd stop right here. You have your list. There it is. But it's deeper than that. And not just because you're honor students, this is on level 7th grade math. It's still deeper than that. It would be me asking much more specifically, such as, what's the probability of getting a product of 18? You can do that from this list, but it's so much faster if instead of a list. I'm not telling you to do a list and then do an array. Do one or the other. Instead of making this list, we could create, yes, another array. Again, try this on your own if you choose. If you'd like to try to make this array by yourself, then just pause the video or let the video keep playing, but look away. I'm going to create this array and I want you to see if you do it correctly. This array is going to show me all the possible outcomes. Here I go. This time it's not dice. My first event is spinning the spinner. So this is the first spin. Spin 1 or first spin. My second event, again, it's not dice, it's spinning a spinner. So this one's going to represent my second spin or spin 2. Second spin. Again, list your outcomes. According to the spinner, I have a 1, 2, 3, and a 6. Those are my possibilities for the first event. A 1, 2, 3, and 6. Well, in the same way, for this spinner, I also have a 1, 2, 3, and a 6. I'm going to list all the possible outcomes of spinning this spinner. Here we go. Okay, spinning this spinner twice. The first time, it can land on a 1, then land on a 1 again. Look at the number I'm about to put right here. You should be able to tell me why I put a 6. If you need to, go back and reread this statement to figure out why I put a 6. Here, I'm going to put 4. You should be able to tell me where this 4 came from. If you said it's because I'm not finding the sums, this time I'm finding the products, you are correct. It's the products this time. So before you move on, I'd stop what you were doing and I would write the word products. Just like the first example. Okay, see if you can beat me. Fill these in. You should know your multiplication facts by heart. 1 times 1 is 1. 2 times 2 is 2, 3 times 1 is 3, 6 times 1 is 6. See if you can keep going. Okay, hopefully that's what you got. And then it gets pretty simple. Now I'm just going to say, just like before, using this array, back to the question I said I would ask you. What is the probability of spinning the spinner and from those 2 spins getting a product of 18? This time not a sum, but a product of 18. Man, look how quick that is. There it is. It's the only one. So that means I have a 1 in, think about what the denominator is, 16 chance. Yes, you're a mathematician. We need to know what 1/16 is. 1/16 is as a decimal. So pause the video, divide 1 by 16, and see if you get this correct. If you did, 1 divided by 16 is 0 and 625 10,000ths. That looks like this. 625 10,000ths. I need to round this to the nearest hundredth, so look right behind it. This is in the thousands place, 4 or less, let it rest, so my decimal would be 0, 6, 600ths. As a percent, that is not 60%, that is 6%. Okay, last thing I want you to add to the bottom of this list, 2 things actually. If I asked you experimental or theoretical, please tell me what you would say. Fill that in. Pause the video, write it down. Okay, let's think about it. Did you spin a spinner? Did our substitute teacher hand you a spinner and say, spin it twice, let's see the results? No? Then it cannot be experimental. The answer we are looking for would be theoretical probability. Please make sure you said the reason it's theoretical, not experimental. Some of you were still struggling with that yesterday. Next, if you spun this spinner 200 times, then predict what would be the likelihood of you getting a product of 2. Pause the video, write that question down, then I'll help you solve it. Okay, this is just like in 6th grade. This is just a proportion question. If I'm trying to figure out 200 times, well, look what I know. I have a 1, 2, I only see 2 of them, 2 out of 16 chance of getting a product of 2. So I'm going to write that down. My chance of getting a product of 2 would be 2 out of 16. I'm asking, what would that chance be out of 100? Oh, I apologize. I'm so sorry. 200. Here's what this means. This ratio tells me if I come up here and I spin this spinner 16 times, it should land on 2 twice. What is the likelihood that I spin it 200 times? What's the likelihood that I get a product of 2? And I'm sorry, I said that wrong. If I spin this spinner twice, the likelihood that I get a product of 2 would be 2. It could come from it landing on a 1 and then a 2, or a 2 and then a 1. Okay, here we go. To figure out how this would be out of 200, 16 does not go into 200 evenly. However, if I take this fraction and I simplify it, if I scale this fraction down, then I can instead say this is also equal to 1/8. And 8 does go into 200 perfectly evenly.